I was sitting at my desk late last night,
Hmm.
just watching my screen. It was incredibly quiet. Beat. But inside the machine, it was pure chaos.
That sounds mildly terrifying.
Right. I wasn't just watching an AI write a block of code. I was watching it split itself into three completely distinct people. A front-end developer, a back-end developer, and a QA tester.
All working at the exact same time?
Yes, simultaneously. They were literally arguing over bugs in the system,
Yeah.
and then, they actually fixed them.
It completely shatters how we usually interact with artificial intelligence. You aren't just giving simple orders to a solitary machine anymore. You're watching a dynamic system correct its own logical mistakes.
Exactly. So, welcome to this deep dive. We are thrilled you are here with us today. To figure out how this actually works, we gathered our sources,
We pulled Anthropic's technical documentation and various developable case studies.
plus notes from our own messy late-night experiments.
Our mission today is exploring the architect's guide to Claude Agent Teams. We are going to deconstruct a massive operational shift here. We are moving from treating AI as a solitary assistant. We are learning to manage it like a fully coordinated digital team.
We will explore what these specialized teams actually are.
Yeah.
We will look at how to set them up properly. We will cover the golden rules of prompting them correctly.
And crucially, we will discuss when you should definitely not use them.
It is a fundamental change in how digital work gets done. But we really need to understand the baseline shift first. What are we actually looking at when we say agent teams?
Let's unpack this core concept. At the center, you have one main Claude session running. Think of this main session as your dedicated team lead.
Okay, a team lead.
Right. That lead essentially creates specialized teammates for the specific project. Each teammate gets a very clear, dedicated job to do. They work completely on their own specific part of the project.
But they all ultimately contribute to the exact same overarching goal.
Yeah.
That structural setup makes a lot of sense conceptually. I like to contrast simple subagents with true agent teams. Subagents are linear AI workers passing tasks to a central boss. They're basically just a very traditional assembly line. Step 1 finishes, and then Step 2 finally starts.
Yes, and most of the time, subagents don't actually talk to each other. Everything has to go through one central place to be processed.
Yeah.
That works fine when your workflow is strictly linear and simple.
But true agent teams operate like a collaborative writer's room. They actually share a single task list among the whole group. They can message each other directly to handle their own dependencies.
That direct messaging changes the workflow quality entirely. You stop getting one flat output from a single AI session. Instead, you get something that feels like real organic production.
Yeah.
One agent builds the code and another actively checks it.
Right, and they handle these feedback loops completely on their own. If the QA agent finds a critical bug in the system, it sends that bug straight back to the development agent. It skips the manager entirely and just fixes the broken code.
The work gets significantly better because it goes through multiple analytical hands. It is a highly structured way to handle complex tasks. The AI can manage shared dependencies without waiting for your input.
Wait, I have to push back on this a little bit. If I am managing a team of 3 distinct AIs, isn't that just replacing my coding work with middle management work? Am I actually saving any time here?
That is a completely valid concern to have. If you manage them poorly, it absolutely becomes a massive time sink. But if you structure the environment correctly, it scales your output drastically. You trade manual typing for high-level architectural oversight.
If they talk to each other directly, who is actually in control?
The main session always steps back to monitor the overarching goal. It watches the progress, but lets the team handle the daily details.
So the main session is a manager, not a micromanager.
Precisely. But to get that manager working properly, you need the right setup. This is where most people make their absolute biggest mistake. They fail the process before the work even officially begins.
Because agent teams are highly experimental right now. They are actually disabled by default in the core system.
Yes, they are. You have to actively enable them yourself. The very best way to do that is strictly locally. You need to change the project configuration file directly within your workspace.
Why do we need to do this locally? Why not just flip a global switch and turn it on everywhere?
Because you really do not want to change your global settings permanently. If you change global settings, every single prompt tries to use Teams. You do not want a complex AI team drafting a simple email.
That makes sense. It protects your everyday workflow from unnecessary complexity. Keeping it local isolates the experiment to one specific project folder. The system only activates the complex architecture when you actively need it.
Exactly. It keeps your overall computational environment perfectly clean. But simply turning the feature on is not actually enough. You absolutely have to train this specific project first.
I have a somewhat vulnerable admission to make here. I still wrestle with rushing the setup myself. I just want to jump in and start prompting immediately. It feels so tedious to stop and write documentation.
It is incredibly tempting to just skip the boring preparation phase. But skipping it guarantees your AI team will eventually hallucinate and fail. You need to copy the official agent team's documentation URL. Then ask your main session to make a master reference guide.
You save that guide in local docs folder right inside the project. That way, the AI team can actually read its own operational rules. It has local guidance right there in the active workspace. It doesn't have to guess how it should behave during execution.
The mechanism here is absolutely fascinating if you look closely. The main session reads that local file constantly during the project. It holds those specific operational rules in its active context window.
Which is just its short-term memory during a single conversation.
Exactly. Then it actively passes those constraints to every single new agent.
So it anchors their behavior against drifting off topic. They just reference the local file during every single interaction. But I have to ask about the prompt structure itself. Why not just put the rules in the main prompt?
Because scattered memory always fades over a long chat session. Checking a local file grounds the AI perfectly and permanently.
Local files give the team a permanent shared brain to rely on.
That shared brain is absolutely critical for long-term project success. But how do you actually command this newly grounded digital team? You need serious structural discipline to make them effective.
If you've ever spent a weekend untangling AI spaghetti code, you already know that a messy prompt equals a messy team. You have to start with a completely clear end state.
Do not just casually say you want to build an app. That is much too broad for a team to handle properly. You must ask for a working app and a detailed QA report. The clearer the end state, the better the team will perform.
Next, you really must keep the total team size quite small. 3 to 5 agents is usually the perfect functional sweet spot.
Adding more agents just rapidly increases your daily token costs. Tokens are the digital price you pay for the AI processing text. More agents also create a massive amount of unnecessary coordination chaos.
If you have 50 agents, the communication overhead becomes utterly paralyzing. 3 to 5 agents keeps the workflow tight and focused. Now let's explore the 3 golden rules of prompting them.
These rules prevent the inevitable disasters of parallel AI execution. Rule number 1 is defining clear territory for your agents. You must define exactly what files each specific agent officially owns.
Because if you don't establish boundaries, they will overwrite each other. The front-end agent might accidentally delete the back-end agent's database connection.
Right, it becomes a total disaster very quickly behind the scenes. Rule number 2 is establishing direct messaging protocols. You must explicitly tell them exactly who to talk to. Tell the developer to send output directly to the QA tester.
Do not ever assume they will just figure it out themselves. Explicit communication instructions make the workflow feel truly connected and deliberate. It builds a reliable chain of command within the digital workspace.
And rule number 3 is embracing true parallel work. Let them work at the very same time on different tasks. Do not force them into a strict sequential timeline.
Wait, if they're working simultaneously on the same project, aren't they going to constantly step on each other's toes?
Not if you followed rule number 1 and defined clear territory. If you force a sequence, you aren't really using a dynamic team. You are just recreating a slow assembly line with extra unnecessary steps. Teams are specifically designed to run complex tasks simultaneously.
That requires a lot of trust in the system's underlying logic. What happens if you leave the definition of done slightly vague?
Agents interpret good enough in wildly different ways. You will just get disconnected, half-finished outputs across the board.
Vague goals breed lazy agents. Define exactly what done looks like. Mid-roll sponsor, read insert placeholder here. Okay, we have set the rules and trained the local project. We gave the initial prompt with a perfectly clear end state. What does it actually look like when we finally hit enter?
The actual execution flow is genuinely fascinating to watch unfold. First, the main session creates the entire team from scratch. It defines the individual roles and sets up a shared task list. Then, parallel coordination instantly starts across the entire board.
The agents start actively sending messages and passing their outputs around. Then, the QA review phase loops continuously to catch any functional errors. Finally, the main session wraps it all up cleanly for you.
Yes. And if you use a terminal environment, the visibility is incredible. Something like a Tmux layout is absolutely perfect for this specific workflow. Tmux is a tool dividing one screen into multiple separate workspaces.
You essentially grid your monitor into different functional data windows. 2-sec silence. Whoa. Just imagine watching multiple AI minds thinking side by side in real time.
It feels exactly like looking directly into the digital matrix. It gives each agent its own visual space on your monitor. You literally see the front-end agent streaming code on the left. Meanwhile, the QA agent is actively writing tests on the right.
You don't have to guess what they are currently doing. That level of visibility sounds absolutely amazing for complex debugging. It is like being the conductor of a massive digital orchestra, and it gives you much tighter control over the workflow, right?
Exactly. You can correct specific agents instantly if they start to grift. In a normal setup, you mostly talk to the main session. But in the terminal, you can step in and redirect anyone directly.
That is incredibly powerful for maintaining project momentum. But I have to ask about the sheer speed of this process. What if the whole process moves way too fast for human comprehension? What if they start building before you can even catch a mistake?
That is exactly when you must use plan approval mode. You ask the AI team to submit a detailed architectural blueprint first. They outline what they will do and in what specific order.
You thoroughly review that plan before they write a single line of code. You check their logic before they start spending your expensive processing tokens. But doesn't plan approval kill the magic of AI speed?
Speed without direction just creates massive cleanup work later. Taking time to plan actually saves you significant time overall.
Slow down the planning phase to speed up the actual execution.
That mandatory planning phase saves you from a lot of frustrating pitfalls. Let's ground this discussion by looking at where the system typically crashes, because it definitely does crash if you manage it poorly.
Yes, let's absolutely talk about the common systemic problems. We also need to discuss why you sometimes should not use agent teams. Pitfall number 1 is dealing with constant permission interruptions.
This specific issue breaks the automated workflow entirely. The agents stop constantly to ask if they can run something. They pause the entire project just to ask permission to read a file. The fix is simply to pre-approve the specific tools they need upfront.
Pitfall number 2 is confusing historical context with mere system access. Agents inherit your core permissions automatically when they are initially created, but they absolutely do not inherit your full conversation history.
Right. They start their existence with a completely blank slate. If you don't explicitly give them context, they simply do not know. You must provide the overarching goals and project constraints up front.
The main session knows everything we have discussed previously, but the newly spawned QA agent was literally born 3 seconds ago. It needs to be briefed on the project before it can actually work.
That is exactly why that local shared markdown file is so crucial. Next on the list of major pitfalls is proper shutdown discipline. You cannot just close the terminal window when you see the final output.
Wait, why not? If the code is finished, why can't I just quit the application?
Never just close the window abruptly. The main session holds critical data in a temporary memory buffer. It must formally tell the individual agents to wrap up their processes. They need to save their progress properly and confirm they are finished.
If you don't do this, you will absolutely lose crucial files. The system terminates before the background saves actually complete. That sounds incredibly frustrating after a long session of productive work.
It is a painful lesson you usually only have to learn once. Now, we really need to discuss when you should avoid this architecture. When does this whole complex setup become a massive operational liability?
Do not use them for simple, strictly linear daily tasks, or tasks needing one continuous, unbroken string of deep contextual memory. If the work is straightforward, one single agent handles it much faster.
Using a team for simple tasks wastes expensive processing tokens unnecessarily. It also badly fragments the final output because active memory is divided.
Adding more agents just adds complex coordination without any real benefit. One single capable agent is much better for quick, simple code-based fixes. Is it safe to say a team is overkill for most daily tasks?
Yes. Teams are strictly for parallel, multi-role digital workflows. Don't use them for simple chores that require minimal intellectual effort.
Don't hire a whole construction crew just to change a light bulb.
That analogy perfectly captures the core theme we're discussing here today. When a Claude Agent team fails, it isn't usually the underlying AI. The underlying AI model itself is generally very strong and highly capable.
The system usually fails because the human's overarching structure is fundamentally messy. Better digital results do not come from relying on technological magic. They come from better, more intentional human coordination and structural discipline.
You have to define project ownership very early on in the process, and you absolutely must make all team communication totally explicit. It really changes how you approach complex digital work entirely.
You are setting up a small, highly efficient digital system. Different specialized roles working perfectly together toward one unified project result. It moves you from being a typist to being an architect.
So here's our final call to action for you today. Try enabling this complex feature locally on a very small project. Just sit back and watch the AI agents pass tasks back and forth.
It is completely mesmerizing to observe the process in real time. It gives you a profound feel for the inevitable future of work. You see exactly how collaborative artificial intelligence will function tomorrow.
It shifts your perspective on what is actually possible with these tools. You realize the bottleneck isn't the machine's intelligence anymore.
The primary bottleneck is usually our ability to organize the machine's effort. Beat. And that leaves us with a final thought for you to mull over.
AI is rapidly moving from an assistant who simply writes for you. It is quickly becoming a complex team you actually have to manage.
How does that massive shift change the fundamental skills you need to develop?
It forces us to rethink our entire approach to daily productivity. The technical skills might matter slightly less in the long run. The organizational skills will suddenly become incredibly vital.
2-sec silence. Perhaps the most valuable skill of the near future isn't doing the work. Perhaps it is being a masterful digital manager. Thank you for diving deep with us today. We will see you next time. Our Uturo music.